Yes, class. So we had completed angular projection in the last class. Let's just quickly revise all the formula and one question we will do. So to wrap up angular projection, then we'll move on to horizontal projection. And horizontal projection is much easier than this angular projection. The formulas are also shorter. Aisha and Aram, how was your test? On Saturday you had it? How was it?
It was good.
You were able to manage? Aram?
Yes, ma'am.
Your class couldn't get arranged on Thursday and Tuesday. Other batches were already fixed. So equation of trajectory was y is equal to x tan theta minus gx square divided by 2u square cos square theta. Then time of flight was 2u sine theta divided by g. Range of motion is u square. Sine 2 theta divided by g. You have our height. Formula of height is u square sine square theta divided by 2g. Fine, then velocity we had seen for x component, you have to write u cos theta as it is. Velocity does not get changed in during this x axis. And for y component, y axis, you have to write u sine theta minus gt. Fine, this is the y axis. Numerical also we had done it, and these were the conditions that were present, that there's no change in the velocity along x-axis, acceleration along x-axis is 0, and the force along x-axis is also 0. Along y-axis, that acceleration due to gravity will only work, and velocity at the highest point is 0. So one easy numerical we did, one more numerical let's do. And then we'll move on to horizontal projection. So from the next class, we'll start with laws of motion. So note this question, take 2 minutes, try it yourself, then I'll discuss it with you. See class, the question says what? A boy stands at 39.2 meter from building. So if this is the building, this will be 39.2 meters. And thrown a ball which just passes. Okay, a ball has been thrown from the building and it just passes through a window 19.6 meters above. Means this is 19.6 meters above. Just a second. 19.6 meters becomes the height. Now we have to find the velocity. See, if you look carefully, 19.6 is given to you as what? 19.6 becomes the height. Because a boy is standing, a ball passes like this. And this distance becomes 19.6. So that is the height. And 39.2 becomes what? It becomes the half of the range, because this complete is what? Complete is range of motion, and only this much is given as 39.2. So 39.2 this much and 39.2 this much. Fine. This is what we have to calculate. So this is the height and this is the this is half of range of motion. You can say we have to double it for the complete range of motion. So if we try to calculate the range of motion, this will become what? See, R will become 2 into 39.2. This will become u square sine 2 theta divided by g. Angle we do not know. We actually have to find out angle first, because if we know angle, then velocity of projection is easier to calculate. U is easier to calculate. Here two variables are there. U is also unknown and theta is also unknown. The rest of the things we are aware of. H we know, R we know, acceleration due to gravity we know. So in these equations, since theta is unknown, no, that's why we are not able to calculate U. Otherwise, calculation of U was not a difficult task. We would have calculated using the formula. The difficulty that is arising is because of the absence of angle that is given. So one equation you have this, other you have height as u square sine 2 theta divided by 2g. Fine. So this is what? This is height. Again here, height is given, u is unknown, theta is unknown, g is given. So it's like two linear equations with two variables, theta and u. These become your variables. So put the value of height. Height becomes what? 19.6 equals to u square sine 2 theta divided by 2g. Now these two equations are mentioned. Now using these two equations, we just have to. So first, let us find out the value of angle. So if you divide these equations, that becomes 2 into 39.2. This is equal to, because u square will get cancelled, no, first. That's why we'll first find out the value of theta. Now it's just two equations. You can calculate in any manner you wish to calculate. So this becomes u square. This was what? Sine 2 theta by u square sine 2 theta by g. So this also becomes what? U square. We can write one more thing. We can write this as 2 sine theta cos theta as well. We can write this as, because if it is better if we get it in one liner, either cot or tan. Otherwise sine and cos, this will become confusing. Sine will get cancelled, u square will get cancelled. Let's write it in this way. It's the same thing only. Divided by height was what? 19.6. Multiplied by u square sine square theta divided by 2g. So g gets cancelled, u square gets cancelled. What is left? 2 multiplied by 2. And what is 2 into 39.6? Just check. 2 into 39.2 you have divided by 2 is present. So from here also sine square theta is present over here, and sine theta is present on the numerator. So you have sine theta present on the numerator and sine square theta present on the denominator. So one of it will get cancelled. So if this gets cancelled, you will just simply have here 2 will be there, this 2 will get cancelled, this 2 will be left, and this is what? This is 19.6. So this becomes 1. This gets cancelled, this becomes 1. 1 sine theta gets cancelled. So simply cot theta is equal to 1, or you can say 1 by tan theta is also you're getting 1. 1 by tan theta is 1. So tan theta will also be 1. So anyways, your theta will come out to be 45 degrees. Got it? 2 got cancelled. Then this 2 became 19.6. 19.6 got cancelled. 1 sine theta, this got cancelled with sine square theta. U square got cancelled. GG got cancelled. You were left only with cos theta divided by sine theta. So which equal to, not cos theta, cot theta. This is equal to cot theta, or you can say tan theta. Both are equal to 1. That is, your theta is 45. Now put it in any of the equation to get the value of u. Let's put it in equation of r. R is equal to u square sine 2 theta divided by g that you have. So r is what? 2 into 39.2. This is equal to u square sine 2 theta. That becomes sine 90, and sine 90 is 1. And this is divided by 9.8, let's take. So u becomes what? Under root 9.8 multiplied by 39.2 into 2. This much meter per second that you can calculate on your own. So basically you had two equations with you, and you had to solve these two equations using your simple concepts of linear equation in two ways. That's it. Height and range you have to identify, and do double the range whenever you write. And note down the solution. Any doubts you have, then we'll start with linear projection. Your horizontal projection is very much easier than this. The formulas are also simpler and relatable. Text me done when you have written it. Any doubts? Yes.
Ma'am, is the answer 27.7?
20. I do not remember the answer. Just somebody else also please calculate and let me know. How much you're getting here?
27.7 meter per second.
27.7 meter per second. Okay, somebody else also please confirm if this under root 9.8 into 39.2 into 2 is 27.7. Because exact answer I do not remember it. So question all of you must have written, no, by now. Shall we start with horizontal projection? Clear till here?
Yes, ma'am.
Others? Aram, Maha, Fatima. Yes, ma'am. And what about you, Abdullah? You're able to understand? Let's start with horizontal projection. Horizontal projection means what? See here, this is easier than what you've studied. Here your projectile. Here what happened? Your projectile, it covered this type of motion. This was the path that was covered by the projectile. So this was what? This was an angle with which you had thrown it. The projectile, it was thrown at an angle. Now, if this angle is 0 with the x-axis, so it means you are throwing a body like this. So this angular part that was existing or that was present, this has now been deleted. This is not present because there is no angle. From 0 degree, your projectile has been thrown. So this path that will be obtained, this is known as horizontal projection. Means your theta is now 0 degrees. Angle that is made with the x-axis, that is 0. It's parallel to x-axis. So horizontal projection. So see this. This part is just existing. This is no angle that is made with the vertical or the horizontal that you have. Initially, this was an angle that we had taken as theta. This is now erased. So here, this becomes the origin now. From here, your projectile will originate and cover its motion. Fine, with certain initial velocity will still exist. U will be the initial velocity. Then this will be some distance x that is covered. This will be your range of motion. Let's say this distance is y. This is some distance x and y that I've taken. I'll define x and y later on. So range of motion, initial velocity, height. All these terms you are familiar with. Initially, earlier that we had seen for angular projection, this height was in the middle because of the angle. Now this height is the beginning. And most of the questions begin like the height of a building is given this much meters and a ball is thrown directly from the window. So this is the case when no angle is given. X is just 2 points I've connected within the x-axis, and y is also just 2 points that I've connected within the y-axis. Fine. Now you have to find out, we are trying to find out first the equation of trajectory, then time of flight, height, velocity, range of motion, everything that will be the same. So equation of trajectory, or you say equation of path followed. Equation of trajectory, and here the formulas also of range of motion and time of flight are easy. Trajectory or equation of path followed. Fine. Now we are just trying to find out the relation between x and y. Now if you focus on x-axis, we are trying to find out the trajectory. So obviously x and y, as I've told you, throughout projectile motion, be it any of the case, vertical, horizontal, any projection, angular projection, you have to separately solve it. So x-axis, we are just focusing and solving it. So here your ux will be what? Initial velocity will be u, no component now. All the initial velocity is towards the x-axis only. There is no initial velocity towards the y-axis. You do not have u sine theta this time. Acceleration towards the x-axis, I've always told you that this is 0 because acceleration always acts downwards. That is your acceleration due to gravity. Find x, we have to find out. So C class, if you see this, x will be equal to ut from here, and time will be equal to x divided by u simply. Earlier it was what? X divided by u cos theta. That is the difference that will come over here. If you look at y-axis, see uy will be 0, but acceleration will be equal to g, acceleration due to gravity. Now, no need to write it as minus because your velocity is not there. No other component is there. So, take the downward direction as positive. Which other quantity is moving upwards? No quantity is now moving upwards. You do not have any quantity that is moving upwards. Earlier you had u sine theta that was acting upwards. So u sine theta acted upwards, acceleration due to gravity acted downwards. Both were in the opposite direction. So we had to choose the sign convention as either one as positive, one as negative. So usually we had chosen negative as downwards, and that's why we could write a as negative minus g. But this time there is no component of velocity upwards towards y-axis. So everything is acting downwards. So why to take downwards as negative? Take downwards as positive. So A as G. Now Y will be equal to what? Ut plus half AT square. So A will be, U will be Uy. This everything will be in terms of Y. T you can put it from here. Fine, you can easily put the value of T. So see, Uyt, this will be equal to 0. And half A by T square. From here, let's put it. So this becomes half. A is G. T is x square divided by u square. This is the equation of trajectory. This is just the equation of trajectory. So you had such a long and lengthy equation in angular projection, the tan theta equation. That was such a huge long equation, x tan theta minus half, and you had cos theta also in it in the denominator, and solving it was also difficult. This time you have what? This time you have it as just half gx squared by u squared. Now, after this, we'll do all things simultaneously, time of flight, range of motion, velocity at any instant, and we'll just move on to the questions. But first, note it till here. Any doubts you have, understand it first. Any queries you can ask, then I'll straight away cover all the formula now after this. So this was the equation of trajectory. Easy to remember, half gx square divided by u square. Or you can remember gx squared by 2u square. Time of flight formula is also easy. The way, see, angular projection, if you have understood, if you have remembered the formula, that's why I'll say first, always, whenever you start revision of this lesson, start with angular projection. If angular projection is done, then rest of the things become easier to remember. Okay, next is time of flight. Let's calculate the time of flight. So time of flight is again, meaning is the same. Meaning is what? The time taken by the projectile to cover this much duration, that is whatever, to cover its equation of trajectory or to cover its path that it has traveled. So this is what? This is time of flight. So see, for time of flight also, if you use this equation for y only, y-axis only, ut plus half a t square. Now your time, see, y is what? Y is the height of the building or the projectile, height of it, that we write. See, uy will be equal to 0. There is no initial velocity along the y-axis. Everything horizontal means along x-axis only. See, this is your projectile, no? This is your initial velocity, that is situated along the x-axis only. This is your y-axis. Now, height is what? This is your height. This is your range of motion. Fine. Now, let's say this point is A, this point is this point is O, this point is A. So time of flight means what? Time taken from O to A. Simple words, you can remember this only. From this origin point to the landing point. Got it? So uy is 0. T is what? T will be here. It will be equal to the time period, time of flight, not the time period, time of flight. A will be equal to acceleration due to gravity. That is your ay, uy, and ay will come into actions. So put this in the equation. H is equal to, this term will become 0, half g t square. So T will be equal to what? 2h divided by g, under root 2h by g. This is the formula for time. Easy to do, easy to remember, under root 2h by g. Range of motion is easier than this. Just multiply u with it. U under root 2h by g. That is the formula of range of motion. T is under root 2h divided by g, na? Range of motion is u multiplied by under root 2h divided by g. See, derivation can come. From here, derivation can come. And be prepared with this lesson. Next week, you will have a test on this. When are your exams ending? All of you just let me know your dates when your final paper is there. Major subject will get over. That I can have an idea of that also. Aisha, Aniram, Fatima, Maha, Abdullah. Range of motion. Range is what? It's the maximum horizontal distance that is covered. That was in your angular projection range of motion was same. Here also range 15th October. Okay, 15th October. So Aram and Aisha will have 15th October. So if we have a test on next Monday, will you all be comfortable? Just see your syllabus and date sheet if no test is around there. Monday, if we have a test.
It's possible.
It's
We
possible?
have maths exam
On?
Saturday, like next week.
Next week, Saturday, no? Means the coming Monday is 26th. So
Yes.
on Saturday, you will have, no? So I think this is a small chapter you'll be able to do.
Yes, yes.
It's okay. And you too, Maha and Fatima? Are you okay with next Monday?
Yes, ma'am.
And Abdullah?
Yes, ma'am.
Okay, next Monday then we'll have it. Okay, now range of motion. So it's again the maximum horizontal distance covered. maximum horizontal distance covered. Fine. Now we'll use obviously x equation because we are trying to find out the range of motion. So ut plus half at square only we'll use, but here everything will be in terms of x. So ux will exist this time, initial velocity of the projectile, because your velocity along x-axis is not zero. It has some value. Time period, we know it's time of flight, that is 2h divided by g, and acceleration along x-axis is 0, so this time this term becomes 0. And what is x? X is your range of motion. Easy. Put here r is equal to ux ut, t is under root 2h by g, because in this case your acceleration becomes 0. Last thing, velocity at any instant. And here you don't have to find out the maximum height or something, because one height is only existing. That will be mentioned to you. So no specific formula for height. Height, if you want to calculate, you can convert. Under root 2h by g was the formula for time period. So you can write t square g divided by 2 from that equation. No specific formula for height, because height this time it's not variable. Once specific fixed height is there, and that is the origin. But velocity at any instant can be asked. Velocity. So velocity along the x-axis is again same thing, class. Same thing we are doing it. And these things are simpler. See, let's say this is the projectiles. This is a random point I have taken. The way I had taken a random point in the last class for the velocity along for angular projection. See, this is some velocity having v. So there will be, let's say this is some angle, theta, let's say, or beta. Beta we had taken in the last class. Let's take it beta here also. So this becomes v cos beta, or I'll write it as x only, component of velocity along x-axis. So vx, and this is what vy. Fine. Now, this is the final point, and the whole time period that will be covered will be capital T. Now, velocity at any instant, if you try to find out. See, class, if we try to find out it along x-axis, because x and y, we have to do it separately. So after some time, let's use the equation v is equal to u plus at. And in your derivations in your exams, use exactly same equations that I have started with. Otherwise, you'll not be able to reach your answer. It will give you a longer method to do. So Vx, this becomes Ux, this becomes Ax. Fine. Ux is what? That is equal to U, and acceleration is 0. Ax is 0. So your Vx comes out to be U. Even from angular projection, if you are able to recall, velocity along x-axis was u cos theta only. There wasn't any change in velocity along x-axis, because that's a condition. I have told you that's a condition for velocity for any object to be covering projectile motion, is that velocity along x-axis does not change. So be it horizontal, be it angular. And velocity along y-axis, this becomes u plus at. This time this will be for y, uy, ay. So uy is 0 and ay is equal to g. So this term this time becomes equal to 0, and this is g. So in your angular projection, what did you have? G sine theta minus something, no? Formula for velocity. U sine theta minus gt. Yes, this was u sine theta minus gt, and this was u cos theta. And here what you're getting, I'll suggest you whenever you study, do at the end make a comparison of both of these. And here you are getting what? Same thing, gt, because u sine theta does not exist. Only gt you are getting it. Now net velocity, if you are asked, that is velocity along x-axis separately, velocity along y-axis separately. If net velocity is asked, then you can write net velocity as Vx I cap plus Vy j cap in terms of this Or you can simply use, if you want to find out the magnitude, you can put under root Vx square plus Vy square. So that here now your vectors play important role. And yes, beta, if it's the angle that is made with the horizontal. Remember, velocity was making an angle beta. So your tan beta here, it will also be equal to Vy divided by Vx. Same things. Fine, just I'm repeating this in quick so that after this we can do numerical practice. One numerical we'll do, then I'll end this. See, horizontal projection, you have equation of trajectory which simply says half gx square divided by u square. Time taken, time of flight is under root 2h divided by g multiplied by u, you get range of motion u under root 2h by g. Velocity along x-axis is u, velocity along y-axis is gt. Net velocity, whatever is asked, magnitude is asked. Calculate the magnitude, only equation is asked, write the equation. If you have to use parallelogram law, use parallelogram law, whatever you have to use, by which anyway you have to find out net resultant. We have studied that in vectors. So by that you can calculate, and tan beta will be equal to Vy divided by Vx. All these are the formula for the angular, for the horizontal projection. From here you have to find out just one more thing, a quick revision with angular projection as well, so that you can relate at least. Angular projections equation of trajectory was what? It was a longer equation. X tan theta minus half gx square by 2u square cos square theta. Horizontal projection, only this part, only this and this. Fine. Time of flight, that here this is 2u sine theta divided by g. There the time of flight for horizontal projection is under root 2h by g. Range of motion is completely different, u square sine 2 theta by g. That time u under root 2h by g. Then you have height. Height, you do not have any heights formula specifically over here. Over there, here you have u square sine square theta divided by 2g. And then velocity's value, you have u vx as u cos theta. Their velocity was u. Here you have u sine theta minus gt. In case of horizontal projection, you have only gt. Fine. So note it from here. One numerical we'll do and we'll wrap up this. C class. It says that an aeroplane flying at an altitude of 100 meter with velocity 10 meter per second drops a packet. You have to find the time taken by the packet to strike the ground. If the packet strikes the ground, the time taken will be time of flight. So that is what that is, under root 2h divided by g. So first part answer will be t is equal to under root 2h divided by g. Into height is what? 100 meters. G is 10. Becomes what? 2 into 20 under root 20, or you can write 2 root 5 seconds. Second part says maximum horizontal distance covered by the packet. So that is range of motion. That is simply range of motion. So range of motion is initial velocity multiplied by time period, or 2 under root h by g. Time period is 10. This is 2 root 5. That becomes 20 root 5 meters. Fine. Velocity with which it strikes the ground. See, Vx will be what? Vx will be equal to u, that is 10 meter per second. And Vy will be equal to gt. The acceleration due to gravity is 10, and time of flight we had calculated as under root 20. So this is your Vy. Vy you have, net velocity will be what? Vx vector plus Vy vector. If we want to calculate the magnitude, that becomes coefficient of the I cap square plus coefficient of the j cap square. This becomes 10 square plus 10 root 20 whole square under, that is the net velocity, this much meter per second. So that will be what? 2100 meter per second. You can use long division and find that. So easy, easier than even your angular projection. Revise this. Next week we'll have a test. Just complete this. When you are done, text me done. I'll stop it. Your lesson is over. We'll start with laws of motion on. Do text me done when you have written so that I can stop the class.